Hi class, my name is Dr. Boyle and I will be your professor for Math 175, Discrete Mathematics this semester. I'm very sorry that I couldn't be with you on the first week of class. I know the timing is terrible, but I have a conference to go to and it was unavoidable. So thank you for watching this video and learning a little bit more about me and how this class will operate this semester. So if you've read the syllabus and if you've watched the two videos that I posted to the course information section of Canvas, you'll know that I plan to implement the flipped classroom model this semester. So what that means in my own words is that instead of the traditional lecturing to you in class and then sending you home to work homework problems by yourself, instead, at home, when you're on your own, you will be watching my lectures via these online videos, which I will post to Canvas weekly. And when you come to class on Wednesdays and Fridays, those 50 minutes we have together each day will be spent working on problems together. I'll call them problem sets. You'll have the opportunity to work in groups. We'll do some problems at the board. We'll have good class discussion. And I think learning the vocabulary and learning the new material before coming to class will just allow us to have a more meaningful time together. So I know this might be new for a lot of you, so if you have any questions or concerns, please email me before the semester starts, and I'd be happy to answer any questions that you may have. So we're taking discrete mathematics. The first question should be, what is discrete math? So discrete mathematical structures include things like sets, graphs, and statements in logic. So we'll talk about each of these things throughout the semester, but graphs, when you hear that word, you might think of something like the graph of a line, or maybe the graph of a parabola. The graphs we'll study in this course are different than those graphs. These graphs will be vertices, which are connected by edges. An example of a graph could be something like a computer network. So what I'm trying to say here is that this is not a course that is similar to something like pre-calculus or calculus, because we're not studying continuous functions. This class really is designed to be an introduction to formal mathematics, and the first part, all of Chapter 1, really will feel like you're learning a new language. We're going to learn to communicate mathematically. So Chapter 1 is called Logical Thinking, and I've included here on this slide some examples of logical fallacies. So for example, our first meme here, cheese has holes. More cheese equals more holes. More holes equals less cheese. Therefore, more cheese equals less cheese. Confusion. Confused face. Our second one, chocolate comes from cocoa, which is a tree. That makes it a plant. Therefore, chocolate is salad. While these would be nice, clearly there are some logical fallacies at play. And in English, that happens. We can get lost in like circular reasoning. Words can be ambiguous. They can mean two different things. And there are lots of ways that English can be very confusing. But in a math class, we never want that to happen. In math, it is very important that we state things precisely because it's still math. We still need our answer to be correct. We should still be able to validate our answer by checking our work. That's one of my favorite things about math. We know our answer is correct if we can play by the rules and check our work. That should still be true. So good mathematical language conveys a clear, unambiguous message. And when you read a mathematical statement, you are meant to take every word seriously. So the goal of Chapter 1 is to help you learn to communicate mathematically by understanding the basics of logic.